Hello everyone. In this video, the main focus is to practice past paper questions related to vectors in mechanics. Today I will be going through 10 past paper questions, and at the end of this video you will be confident in how to find resulting vector, how to resolve vectors, and how to draw a vector diagram for a particular problem. So let's get started. So the first problem from 2012 past paper. A model boat is crossing a stream. The stream is traveling east at a speed of 1.5 meters per second. The boat is heading north at a speed of 0.5 meters per second. The magnitude of the resultant velocity is, so there are four possible answers are given. It is probably a good idea to start off by sketching the four directions, north, east, south, west, and the streamline with the boat indicating the vectors. The boat will experience 1.5 meters per second to east because the stream is flowing to east, and since the boat is traveling to north, it will have 0.5 meters per second to north. Now let's draw a vector diagram for this. 1.5 meters to east and 0.5 meters per second to north. We can draw the resultant velocity by joining the ends of these two vectors. Since this makes a right angle triangle, we can calculate the hypotenuse or the resultant vector using Pythagoras theorem like so. The boat will travel in the direction as the resultant velocity we just found like so. Problem 2. The diagram shows the forces acting on a picture of weight W suspended by a cord. The tension of the cord is T. Which of the following expressions shows the correct relationship between W and T? In this problem, we know that the triangle makes an equilateral triangle since two sides experience same tension. We also know that in an equilateral triangle, the opposite angles to the two equal sides are also equal, and therefore the unknown angle can be found as theta, like so. Now we can resolve the tensions acting on the two chords in vertical directions and horizontal directions like so. Since the picture is vertically balanced, we can write all the vertical forces acting upwards should be equal to the forces acting downwards, and therefore T sine theta plus T sine theta is equals to weight, and therefore 2T sine theta equals to W. Therefore the answer is D. Problem 3. Below is a free body force diagram for the balloon when a wind is blowing. Upthrust 10,200 newtons upwards. Force due to wind 300 newtons left. Weight downwards 9,800 newtons. The magnitude of the resultant force acting on the balloon is. So again, four possible answers are given. So we can simplify the free body diagram vertical component by simply subtracting upthrust minus weight. Since upthrust is larger than the weight, the resultant vertical force acts on the body upwards. Now we can draw the vector diagram. 300 newtons left horizontally, 400 newtons upwards. Again, since this is a right angle triangle, the resultant force can be calculated using Pythagoras theorem. This will be the square root of 400 squared plus 300 squared, and this will result 500 newtons. Therefore, the answer is B. Problem 4. A person is standing at point C in a train carriage traveling round a sharp bend to the right. The person jumps up. Nearest which marked point is the person most likely to land? There are four answers given, A, B, C, and D. I've added an interesting animation for you to understand the answer to this problem. So let's have a look. If the bend is not sharp, the person will land on mostly B. But since this is a sharp bend, it makes a larger angle within a very short period of time. And since the bend is very narrow, most probably this person will land on A as shown in the animation. Problem 5. A climber slides down a rope attached to a rock face as shown in the photograph. Select a possible free body force diagram for the climber. Now let's see what are the forces acting on this person. Tension indicated in red, which is the pull by the rope. Weight acting downwards. Normal contact force acting horizontally to left, which is the push by the rock. So if we try to draw the free body force diagram for this person, it will look like this, and the answer is C. Problem 6. The diagram shows an object on an inclined surface. The component of the weight W parallel to the surface is. We can find the angle between weight and the normal contact force R, theta as shown in the picture. Now we can resolve the W in two directions. One which is parallel to the inclined surface and the other one perpendicular to the surface. Now question asks for the parallel component, which is W sine theta, and therefore the answer is D. Problem 7. A car travels 90 meters east and then 50 meters north. A vector diagram is drawn with a dashed line representing the resultant displacement, which is a correct vector diagram for the displacement of the car. Car moves 90 meters east, or A to B in the diagram, and then to north, or B to C, 50 meters. Therefore, the displacement direction is A to C. This is only correctly shown in figure B. Therefore, the answer is B. Problem 8. A kite is held by a string and flies because of lift produced by the flow of air. Figure 2 shows a free body force diagram for the kite. Sketch a labeled vector diagram to show that the four forces are in equilibrium. In this problem, we have to draw a vector diagram to show that these four forces are balanced. If the forces are balanced, this should result a closed polygon connecting all these vectors. So let's try to draw this. Weight downwards. At the end of weight, let's plot drag. At the end of drag, let's plot lift, which is acting upwards. At the end of the lift, let's plot tension. This is giving an enclosed polygon like this, and therefore this is the answer to this question. Problem 9. A body is acted on by a vertical force of 18 newtons and a horizontal force of 32 newtons. There are two parts in this problem. Let's first draw the vector diagram for this problem. 32 newtons horizontally to left, 18 newtons upwards. Therefore, the resultant force given by the hypotenuse, square root of 32 square plus 18 square. Therefore, the magnitude of the resultant force is answer C for the second part of the question. Now let's find the angle to the horizontal, which is theta. Tan theta is the opposite side divided by the adjacent. Therefore, tan theta is 18 divided by 32 in this case. And theta can be calculated as tan inverse 18 over 32. Therefore, the answer for first part is answer B. Problem 10. The diagram below shows the child at a point P where both sides of the cable make an angle of 2 degrees to the horizontal. Add labeled arrows to the diagram to show the forces acting on the cable at the point P. Second part, the total mass of the child and seat is 40 kilograms. Show that the tension in the cable is about 6,000 newtons. So let's draw the free body force diagram for the child. Tension makes 2 degrees to the horizontal and weight is acting downwards. If we resolve the tension into its vertical and horizontal components, we get t sine 2 vertically and t cos 2 horizontally. For the vertical balance of the child, we can write t sine 2 plus t sine 2, which are the upward forces, equals to W, or mass times gravity, the downward force, and hence 2t sine 2 equals 40 kilograms times 9.8, the gravity, and therefore t can be given as 40 times 9.8 divided by 2 times sine 2, which is 5616.12 newtons, which is about 6000 newtons, which is the answer. So in this video, as I promised, we went through 10 past paper questions. I hope you are now confident in vector problems. If you found this video helpful, please thumbs up and subscribe and leave your valuable comment down below. Thank you.